In this session, we'll discuss about applications of FFT. There are two major applications. One is linear filtering and second is spectral analysis. Linear filtering means to find output of digital FR filter for any given input, say X of n. Output of FR filter we'll have to calculate. Now, to find this output of digital FR filter for any given input, we require impulse response of FR filter, that is H of n, and any input when you apply it to this filter, the output is linear convolution of X of n with H of n. This linear convolution can be calculated by many ways. This linear convolution we can always do it by linear convolution formula method, linear convolution by circular convolution formula method, linear convolution by DFT formula method, linear convolution by FFT algorithm, but none of the method mentioned above is suitable for real-time application, because for real-time application entire input signal is not available and the end of this signal is not known, and therefore this method cannot be employed for real-time application. Limitations of linear convolution by FFT algorithm. So as mentioned earlier, algorithm is not suitable for real-time application because in real-time application entire input signal is not available, whereas whenever you have to apply the input to the FFT flow graph, the entire input has to be available because the processing is done parallelly, and when the processing is done parallelly, calculations are done in a fastest way. Examples of real-time applications include ECG monitoring system, digital telephone system, weather monitoring system, and many more like this. So limitations of linear convolution is also continued for long data sequence which is not a real-time signal. Let's say the digital song is captured with a sampling frequency of 44.1 kilohertz, and when the signal is captured with this value of sampling frequency, the number of samples are very long. If number of samples increases, then number of stages in FFT flow graph will also increase and the processing time will also increase, because all these values are applied parallelly and number of stages increases, the processing time also increases. In ECG monitoring system, weather monitoring system, end is not known. The processor works continuously on monitoring, and therefore this is also not suitable for FFT algorithm approach. So how to solve this problem? New algorithm, that is overlap add method and overlap swap methods, are developed to find output of either long input sequence or real-time sequence. Both the cases are for long input sequence. Overlap add method and overlap swap methods are based on block processing of input. So we'll take one by one. First we'll take linear filtering using overlap add method. So in this method we have to decompose X of n into L point sequences. Obviously this L is supposed to be the finite length sequence, user defined sequence. Then you have to select this value of n. N has to be greater than or equal to L plus m minus 1. We have to append this H of n by appropriate number of zeros. We have to append this X of n by appropriate number of zeros because we have to make the length of both the input signal equal. And then we have to find X of k, we have to find H of k. So let's say this is Xi k because the ith decomposed signal block of X of n, ith block of X of n, and that will process to find FFT. Then we'll calculate ith sequence y of k by multiplying these two blocks. Then we'll calculate y of n by inverse FFT algorithm, and by scaling we'll get required y of n. Now to calculate this y of n, we have to do addition of overlap components. So this we'll discuss by example. Let's say X of n is given, that is 202021. Assume that this X of n is actually long sequence, but for manual calculation point of view, a short length in sequence selected. H of n is delta n plus 2 delta n minus 1 plus 3 delta n minus 2 plus 4 delta n minus 3. Actually it is 1, 2, 3, 4. So we have to first decide what value of L we should select. I recommend to assume n equal to 8 for manual calculation point of view, and for radix algorithm n has to be 2 raised to any power. So when n is known, m is known, m is the length of h of n, L can be easily calculated by evaluating this expression. We get L equal to 5. Now we have to decompose this x of n into 5-point sequences. So first sequence x1 of n, 1, 2, 3, 4, 5 values, that is 2, 0, 2, 0, 2. And in the second part we are getting actually only 4 values. So first step, we will make every decomposed signal of equal length by appending the signal by 0. Then all the input signals will have to make 8-point sequence, because n we have selected as 8, again by 0 padding. H of n is also made 8-point sequence. Now next step is to find circular convolution of, basically it's a convolution. Convolution of x1 of n with h of n using FFT, convolution of x2 of n with h of n using FFT. So let's do this step by step. Because this is manual calculation, instead of doing FFT, we'll do it by time domain method for easy understanding. This is circular convolution formula. This is input sequence, and in the matrix row signifies h of minus n. Every shifted signal we have to multiply 1 by 1 with x of n, and we will get this answer. Row multiplied by column, first row multiplied by column will get 2, second row multiplied by the column will get 4, and so on. Similarly, we will find y2 of n using circular convolution formula. I repeat again, we are doing this manual method, and therefore time domain formula method is selected. When we do practically, we have to use FFT algorithm. FFT algorithm, manual calculation point of view, will be very tedious for calculation. So now we have to add these two signals by shifting the second signal right hand side by L. So here L is 5. So first we'll take y1 of n. Then we'll take y2 of n shifted right side by 5. We'll take 5 zeros in the beginning, and then each signal values one by one we'll simply add it. You'll get this answer. This method is called overlap add method, because in this method, this two signal, first signal, last part of the first signal is overlap with first part of the second signal. Whatever the portion is overlap, that we'll have to add, and therefore it is called overlap and add method. Now if you calculate this linear convolution by linear convolution formula method, we will get the same answer. Let's do this by overlap and save method. In this method also we'll have to decompose x of n into L point sequence. We will do it directly by example. So I have taken the same example. First we'll decompose x of n into 5-point sequences. In this method, sometimes we require one additional signal. Many times it is not required. We don't know in the beginning whether it is required or not required. I always assume that it is required, and considering that assumption, I added one extra signal with values equal to 0, 0, 0, 0, because after the last value in x of n, there are no values. Now x1 of n is 5-point sequence, x2 of n is 5-point sequence, extra 0 is added to make it 5, and x3 of n is taken 0. All values 0. Now next part is we have to modify this input sequence. This is something different. To modify this sequence, all these three signals will have to modify. We have to make every signal length equal to 8. To make this value 8, the required sample we have to take from the previous sample. For example, in x2 of n, presently there are 5 values. We need to add 3 values. So those 3 values are added in the beginning of the sequence by taking the last part of the previous sequence. 202 brought in the beginning, 210 will be brought in the beginning, and the first signal we have to add 0. Because x3 of n is values are not non-zero now, we cannot ignore it. We have to consider it. For h of n, no change in the concept. We have to append a signal by zeros to make the length equal to 8. Now we have to simply find, we have to calculate x1 of n convolution with h of n, x2 of n convolution with h of n, x3 of n convolution with h of n. In practical application, we have to do it using FFT. For manual calculation, we will do it using formula method by taking the values in matrices. The matrix are obtained by multiplying row by column. We will get this answer. Similarly, we will do it for y2 of n. This DFT matrix will remain, this input matrix will change and we will get the required appropriate value. Similarly, the third matrix x3 of n is changed and we will get the value. So after obtaining y1 of n, y2 of n, y3 of n, we have to obtain the required y of n. In x1 of n, x2 of n, x3 of n, we added 3 values in the beginning of the input sequence. Therefore, we have to discard 3 values from the every output sequence. And whatever the part is overlap, that we have to save. Whenever we save one after the other. So first we'll save 2, 4, 8, 12, 8. Then we'll save 13, 8, 13, 9, 8. Then y3 of n 11, 4, 0, 0, 0. And we'll get this. This answer is exactly same as what we obtained using linear convolution formula method as well as overlap add method. So every method will get the same answer.
Coursera is an online learning platform designed to provide high quality structured education in a flexible and accessible way. The platform offers academics and professional courses across science, technology, engineering, and management. Visit www.coursera.in. Midnight Masterclass is a YouTube channel and we welcome you to Midnight Masterclass, your late night destination for learning that is actually fun.
Thank you.